If there's one thing our planet loves to do, it's throw a tantrum. Massive swirling storms that can stretch for hundreds of kilometers, tear through cities, and churn the sea like a blender on rage mode. We call them tropical storms, and when they really level up, hurricanes. Let's explore this. Hello there and welcome back to Star Stuff. In this episode, we'll explain what actually makes these monster storms spin to life, why they get such specific names, and what storms look like in other worlds out there in our solar system. Everything begins in the tropics, those warm oceanic zones where the sea surface temperature sits above 26 degrees Celsius. That's about 79 degrees Fahrenheit. When ocean water warms, it evaporates and rises, carrying huge amount of heat energy with it. As this moist air climbs higher, it cools and condenses into clouds, releasing heat, what we call latent heat of condensation. That heat fuels even more rising air, creating a self-sustaining cycle. The Earth's rotation gives it a spin, and before long that column of air begins to rotate. If the winds reach 63 kilometers per hour, it's called a tropical storm. Once they hit 119 kilometers per hour, it is officially a hurricane, or a typhoon or cyclone, depending on which ocean you're in.
Hurricanes are huge. They can be 10 miles high and over 1,000 miles across. Once a hurricane hits land, it runs out of warm, moist air and its winds begin to weaken.
So yes, it's basically a feedback loop of heat, motion, and chaos, powered by the sun and sculpted by Earth's spin. You've probably heard of the eye of a hurricane, the calm and the chaos. At the storm's center, the air actually sinks instead of rising. It's eerily quiet there, like nature taking a deep breath while everything around it screams. Around the eye lies the eye wall, a wall of thunderstorms so fierce it holds the storm's strongest winds and heaviest rain. That's the zone pilots avoid like the plague.
Thankfully, we have weather satellites that are constantly monitoring the conditions down here on Earth. The GOES-R series of weather satellites scan the hemisphere every 10 minutes and the US every 5 minutes, keeping an eye on conditions that might cause a hurricane to form. Once a hurricane forms, the satellites can help predict the storm's intensity and track it minute by minute. This information allows meteorologists to deliver early warnings and help people stay safe.
Okay, so why do we give these spinning disasters names like Katrina, Andrew, or Ida? Back in the day, storms are identified by coordinates and dates. So it's pretty boring. But that got confusing fast when multiple storms hit the same area. So meteorologists started using names. Originally only female names in the 1950s. Yes, really? By 1979, we switched to alternating male and female names for fairness and clarity. Each ocean region has a rotating list of names managed by the World Meteorological Organization. 6 lists of names are used, with the same list being reused every 6 years. For example, the 2024 list will be reused again in 2030. The names on each list are used in alphabetical order for the storms of the season. If a storm causes catastrophic damage, that name is retired forever out of respect. You'll never see another Hurricane Katrina, Hurricane Melissa, or Typhoon Haiyan on the charts again. Now that we know how Earth does it, let's look at our cosmic neighbors. Because compared to their storms, our hurricanes are just warm-ups. On Jupiter, meet the Great Red Spot, a storm that's been raging for at least 350 years. It's so massive, it could swallow Earth 3 times over. It's a high-pressure anticyclonic storm, fueled by Jupiter's deep atmosphere and fast rotation. Basically, Jupiter's weather report reads, "Still stormy, has been since the 1600s."
You've seen that thing on Jupiter, that storm that never quits. Isn't it suspicious to you that a storm there could go on for 350 years without a break, and we never have storms that go on for 350 years without a break?
So, first of all, when we have storms, it's in our atmosphere. We rotate once a day, and so that rotation creates what we call a Coriolis force. The Coriolis force is heightened if you spin faster. So what is Jupiter? It's 1,000 times bigger than Earth. It's mostly gas, and it rotates once in about 10 hours. You want to talk about ferocious Coriolis forces? We have storms that last weeks here, hurricanes that pick up on this little speck we call Earth that has this much atmosphere on it. Go to a planet that rotates twice as fast, is 10 times as wide, 1,000 times the volume, and is mostly gas, and you're complaining that it lasted 300 years?
On Saturn, there's the hexagon storm. Yes, hexagon, spinning around the planet's north pole. It's a six-sided jet stream pattern that somehow stays perfectly shaped, like nature's own geometry lesson.
Polar vortex. It's a large area of low pressure and cold air that surrounds the poles. Saturn has them too. There's one on the South Pole and one on the Northern Pole, but the Northern Pole's storm looks kinda odd. It's shaped like a hexagon. The Earth's polar vortex has a wonky shape, mainly due to mountains, oceans, and other features that affect the path of air. On Saturn, however, there's nothing to disturb the polar vortex. The planet is just gas. This means that the vortex here can be very symmetrical and orderly, governed by only atmospheric forces. The hexagon-shaped pattern was first found in 1988 in images from NASA's Voyager 2 on the left, caught in 1981. But NASA's Cassini spacecraft has obtained higher resolution pictures of it, such as the one on the right.
On Neptune, we've seen the Great Dark Spot, a violent, short-lived storm with winds reaching up to 2,100 kilometers per hour. That's faster than sound on Earth. Neptune is so cold and so far from the sun that scientists believe its storms are powered by internal heat escaping from deep within the planet. Mars, the red planet, has dust storms that can engulf the entire planet for weeks. Imagine standing on Mars and watching the sky turn orange, then red, then completely opaque for months. It's beautiful and horrifying. Venus wins the award for most unpleasant weather ever. Its entire atmosphere rotates faster than the planet itself, with sulfuric acid clouds and winds up to 360 kilometers per hour. It's like a constant global hurricane in a toxic sauna.
Venus also has a thick, layered atmosphere. It's full of clouds that rain sulfuric acid and whip around the planet at speeds up to 224 miles per hour, faster than some Category 5 hurricanes. The atmosphere is so thick that it creates a surface pressure similar to what it would be about half a mile deep in the Earth's oceans. The atmosphere is made of greenhouse gases, primarily carbon dioxide, which create an extreme case of global warming. They trap the sun's heat, causing surface temperatures to rise over 880 degrees Fahrenheit, making Venus the hottest planet in the solar system.
Studying storms here and out there helps us understand how energy moves through atmospheres, how planets maintain balance, and even how climates evolve. Earth's hurricanes remind us that our planet is alive, dynamic, and dangerous. But they all link us to every other world that dances with the chaos of weather. In the end, storms, no matter how violent, are proof that the planets breathe. So next time you see a storm brewing on the weather report, remember it's not just Earth showing off. It's the universe reminding us how powerful nature can be. If you enjoyed that little breakdown, please give this video a like and subscribe to Star Stuff for more about the cosmos that obviously has a little bit of a temper. Cool beans.